all. Today we're going to do Algebra 1, Chapter 7.7, which is factoring special products. And if you look back to 7.3, we multiplied those special products. Today we're going to undo those and factor them. There are two types of special products that we're going to factor today. And the first one is called differences of squares. And if you look at this, so remember the other word for differences is to subtract. So we're going to subtract perfect squares. Okay, so if we look here, we're subtracting. There's my subtraction, and then I have something squared minus something squared. This is called a difference of squares. When you factor a difference of squares, it factors into conjugates. And conjugates are that same binomial, except one of them is a sum and one of them is a difference. The reason this works is because when you were to FOIL this, outside would be a negative AB, inside would be a positive AB, and the middle terms cancel, which gives you this as a binomial over here and not a trinomial. So let's see what these look like. Looking at your extra practice, so these are all going to be differences of squares, and that's what you have to look for before you start. So are these all differences? Are these all minus of squares? Are these all two things that are squared? So is your first term something squared, and is your last term something squared? And let's go ahead and look at that something. What squared makes s squared? It's s. What squared makes 49? That is 7. So this is a difference of two things that are squared. So what this is going to factor into is actually s plus 7, that's a parenthesis there, and s minus 7. And you're done. That's your answer. If you were to FOIL this, first gives you s squared, outside gives you a negative 7s, inside gives you a positive 7s, those are going to cancel, and last gives you negative 49. So you have your s squared and your negative 49. So when you're doing these, you just want to check, is your first term something squared? In this case it's t. Is your second term something squared? In this case it's a 9. And then it just factors into t plus 9 and t minus 9, so that if you were to multiply them together, those middle terms will cancel because they're your conjugates. Number 3, if it kind of looks like it's backwards, right? You got your x squared as your second term. Do not switch them. Just leave it as it is. Okay, is the first term something squared? Yes, it's 4. Is the second term something squared? Yes, it's x. So it is a difference of squares. So this one's going to be 4 minus x and 4 plus x. And just leave it just in that order. There's no need to switch terms around. Why don't you go ahead and pause the video and see if you can do the next 3. They do have leading coefficients, so just ask yourself what squared makes those. So hopefully you found out what each one squared was. So like 4g squared is 2g all squared. Okay, so when you separate them, 2g and 2g, plus 5 and minus 5 to make your conjugates. 36h squared is 6h that's being squared, so you have 6h plus 11 and 6h minus 11. And this is another one that's kind of backwards, and just leave it in that order. So 9 squared makes 81. 7k squared is what makes 49k squared. So you got 9 plus 7k and 9 minus 7k. So that's differences of squares. Up next are our perfect square trinomials. These are the ones that would factor into two of the same thing. So they have a very specific pattern that they follow. So you have your first term that's squared, you have your last term that's squared, and in the middle you have twice the product of a and b, which would be like the first and the last term. When you factor these, they factor into two of the same things, and you don't even have to necessarily know that you have a perfect square trinomial. So an example would be if I have x squared plus 6x plus 9, which we see up there, and I just want to factor it like we did in 7.5. I'd make two empty binomials, and I'd ask myself what times what makes x squared, and that answer is x times x. And then what times what makes 9, which is either 1 and 9 or 3 and 3, but I'm going to try 3 and 3 because that's then how I'm going to make 6. I look at this sign, which tells me my signs are the same. I look at this sign, which tells me they're both positive, so I know that they're both plus. So if they're the same, do I have to write it twice, or can I just write it once and square it? And that's what a perfect square trinomial is. You can literally think of a square, and the sides are the same. So if this side is x plus 3, then this side would be x plus 3, and this would be a perfect square. So let's look at the extra practice and see what these look like. So as a check to see if it is a perfect square trinomial, you're going to ask yourself, is the first term something squared? And it's an x. Then you're going to ask yourself, is the last term something squared? And that's going to be an 8. Then what I want you to do is I want you to multiply those together and make 8x. And then I want you to times it by 2. Okay, so that'd be 16x. If that is your middle number, then you have a perfect square trinomial. All of this that I have written out right here, all of this is the check to see if you have a perfect square trinomial. So if all of that works, it is a perfect square trinomial. This number right here is your A, this number right here is your B, and it factors into A plus B squared, and that's your answer. You can check this by actually taking x plus 8 times x plus 8 and foiling it out and making sure that you get back here where you started. Okay, so let's look at that again. Is the first term something squared? It's a p. Is the last term something squared? It's a 14. I want you to multiply those together. It'll be 14p. And then you're going to take that times 2, and that's 28p. And if that is the middle number, then you have a perfect square trinomial. And you're going to factor it into p plus 14 squared. Now, if this makes absolutely no sense to you, you can go back and factor how we were just factoring in the last section. You do your two empty binomials. Okay, you go what times what is r squared? That's r times r. And then what times what is 169? Well, I'm going to think it's 13 and 13. And then you're going to look at your signs. Both my signs are the same. They're both negatives. You can leave it like that, or you can say, well, hey, instead of writing it out twice, I'm just going to write it out once, and I'm going to square it. Why don't you pause and see if you can do the next 3? They're going to be a little bit different because you have a leading coefficient again. All right, check those answers and see how you did. The last thing we're going to do real quick is solve. And remember, to solve, we use what's called the zero product property, which means it needs to be equal to 0. And obviously I can't spell and talk. All right, equal to 0, written as a product, which is multiplication. And then we're going to take our factors and set them equal to 0. So looking at the first one here, I happen to know this is a difference of two things that are squared because we have x that's being squared and we have 12 that's being squared, and it's a difference, so this is going to factor into x plus 12 and x minus 12 because remember they're conjugates because the middle term disappeared. Then you're going to set both factors equal to 0, and your answers are going to be negative 12 and positive 12. And then let's jump to the end here. I'm going to run out of room for 20. On 20, you are going to want to minus that 49 first. So I'll do that first step for you. So that you have 9y squared minus 49 equals 0. And then that again is a difference of squares. 3y minus 7, 3y plus 7 equals 0. So you're going to set both factors equal to 0. And this one, you're going to have 2 steps for each. So make sure you add the 7 and then divide by 3. I'm going to combine my steps here. And the other one, you're going to subtract the 7 and divide by 3. So there's my two answers for that one. And the last one down here is a perfect square trinomial. So go back and reference before, but I'm going to tell you it's going to factor into c plus 7 squared. You only need to set c plus 7 equal to 0 once because they're going to have the same answer. Just remember way back we did call that a double root. Alright, that's what I got for you today. Let me know if you have any questions.